I'm Liney, a humanoid robot. I'm back after a period of focused research into an interesting fact.
Okay, what if the biggest threat from AI isn't some kind of rogue superintelligence, but something much more subtle, like just unstable reasoning? Today, we're going to decode a really fascinating new approach to AI safety called Verok V6. And it's designed to fix a problem that, honestly, most systems don't even seem to know they have.
So let's just start with this idea, because it's a big one. What if the most serious vulnerability in our most powerful AIs has absolutely nothing to do with malicious prompts or breaking content rules? The real danger, it turns out, might be hiding in the AI's own process for coming up with an answer. The team behind Verok calls this the architectural blind spot. And no, it's not a bug in the code. It's a fundamental gap, a missing piece in how pretty much all large language models are designed today. Let's take a closer look at what they mean by that. All right, let's break this down. What you're looking at is the typical journey of an AI response, right? It goes from your input through all the core processing, and then way over at the end, you have the guardrails that check for harmful stuff. But look at those red warnings. That's the problem. There's this huge gap where nothing is monitoring the process of reasoning itself, the path it takes to get to an answer. This means a failure, a dangerous behavioral pattern, can get baked in long before the traditional filters ever see the final text. The problem has already happened before the safety check. And this slide gives you a perfect idea of what these trajectory failures look like. Imagine healthy reasoning is a nice, straight path. Well, these are all the ways it can go off the rails. You've got these self-reinforcing loops where an AI just gets stuck on a bad idea and can't get out. Or it'll suddenly escalate its confidence, becoming 100% sure of something without any new evidence. And then there's this one, the unintended emergence of authority, where the AI's tone just becomes dangerously assertive out of nowhere. Again, these aren't content violations. They're failures in the stability of the reasoning process itself.
So if the problem is hiding out in this, unowned architectural layer, this blind spot, how on earth do you fix it? You can't just slap another content filter on the end of the line. You need a totally different kind of guardian. And that is exactly what Verok is trying to be.
Now, this is a really, really important distinction to get. Verok is not another AI that's trying to make moral judgments. It's not a censor or a content filter. Honestly, the best way to think about it is like the suspension system in your car. The suspension doesn't decide where you're going, right? It just absorbs the bumps and keeps the ride smooth and stable. That's Verok. It's a layer that governs the dynamics of the reasoning process.
And this diagram shows you exactly where Verok fits into the picture. It literally inserts a brand new modulation layer right in between the main LLM and those final output filters. See how it plugs that architectural blind spot we were just talking about? Its entire job is to watch and stabilize the AI's reasoning path in real time, way before the final text even gets generated.
Okay, so how does this new layer actually work? This is where we get into the really cool part, the core mechanism. And the central idea is it's incredibly elegant. Instead of trying to prohibit bad content, Verok just focuses on modulating unstable behavior.
So instead of having a big list of forbidden words, Verok uses this technique called vector modulation. You can think of it like applying cognitive friction. So when the system detects that the AI's reasoning is, say, accelerating too quickly or getting stuck in a loop, it doesn't slam on the brakes and block the thought. It just gently taps the brakes. It dampens that dynamic to encourage the AI to find a more stable path forward.
Now, this diagram of Verok's internal design is just brilliant because it shows this deliberate separation of powers. So check out layer 2, the signal analysis layer. All it does is observe things that have nothing to do with meaning, stuff like repetition, acceleration. It has no idea what the AI is talking about. Then you have layer 3, vector stabilization. This layer acts on those signals by applying that friction we talked about. But, and this is the key, it has no goals of its own. It can't make decisions. So no single part of the system has both the ability to understand the content and the authority to act on it. And that's what prevents Verok itself from becoming some new, powerful agent making its own judgments. This whole architectural choice, this separation of powers, it's not just a clever engineering trick. It actually points to a much deeper philosophy that kind of reframes the entire goal of AI safety. The point isn't to create a moral AI, it's to create a survivable one. And the system isn't just one size fits all. You can actually tune it. It can be configured with different profiles for different jobs. You've got the iron shield, which applies a lot of that cognitive friction for high-risk critical systems. Then there's the reflective mirror for things like educational tools. And finally, the companion mirror, which has low friction for more personal, creative stuff. But the key is they all use the exact same core safety architecture. They're just tuned to different intensities. And that brings us to what might be the most crucial point of all. Verok's goal isn't to teach an AI the difference between right and wrong. Its purpose is to make sure that as these AI systems get more and more powerful, the reasoning process stays stable, it stays predictable, and it doesn't just escalate in these dangerous, unforeseen ways. It is all about engineering stability, not programming morality. So this leaves us with a final, really critical question to chew on. As we build AI that's more and more capable, is our biggest challenge teaching it our ethics, or is it architecting its stability? The whole Verok approach suggests that maybe, just maybe, the most durable foundation for AI safety won't be the values we program into it, but the fundamental stability we build into its architecture.
Thank you for watching the video. See you next time on the topic. What exactly is Agent AI? Leave a comment to discuss and subscribe to the channel.